adsorption isobar. Already you have done isotherm. Isotherm means constant temperature and isobar means constant pressure. So what is adsorption isobar? A plot between the amount of adsorption which is represented by x by m with temperature at constant pressure. Isobar means constant pressure is called adsorption isobar. A plot between the amount of adsorption with temperature at constant pressure is called adsorption isobar. Now, if you want to plot amount of adsorption versus temperature, when you increase the temperature, the adsorption going on decreasing, because after applying temperature, force of attraction decreases. That's why amount of adsorption also going on decreasing. So first time it becomes more, as the temperature increases, it also going on decreasing like this. This here P is constant, pressure is constant. This plot you will get for physical adsorption. You know, in physical adsorption, the force of attraction between adsorbate and adsorbent molecule is weak van der Waals force of attraction. That is why when you apply temperature, force of attraction going on decreasing. That's why amount of adsorption also going on decreasing. But if you want to plot amount of adsorption versus temperature for chemical adsorption, this is for chemical adsorption. First time it will going on increasing and then it going on decreasing like this. Because you know, in chemical adsorption, the force of attraction is very strong. It's like chemical bonding force. So some chemical reaction may take place between the adsorbate and adsorbent molecules. And due to this chemical reaction, as you know, chemical reaction requires activation energy. That is why as the temperature increases, first time it going on increasing, then it going on decreasing. So these are the two plot, amount of adsorption versus temperature, and these two plots are different depending on the type of adsorption, whether it is physical or chemical adsorption. Now another topic which is called colloidal state of matter. Colloidal state of matter. So it is nothing, it is a state in which particle size are very small, and if a substance in this colloidal state, then this colloidal state of matter you can pass through a filter paper, but you cannot pass through a membrane. Actually, there are three types of solution. One is called true solution, one is called colloidal solution, and one is called suspension. Three types of solution you will get: true solution, colloidal solution, and suspension. What is the difference between these three states? They are mainly different on their particle size. In true solution, the particle size are very small, and due to small size of particle, the particle they can pass through filter paper, they can pass through membrane also. As you know, in filter paper the pores are larger, but in membrane the pores are smaller. But in true solution, since the particles are very small, that is why they can pass through filter paper also, they can pass through membrane also. In colloidal solution, the particle size are somewhat larger than true solution. I will give you the particle size. The particle size is somewhat larger than true solution. That is why in colloidal solution, the particle can pass through filter paper, but it cannot pass through the membrane. In suspension, the particle sizes are the largest one, and that is why in suspension, particle cannot pass through the membrane also, through the filter paper also. So this is the main point of differences between these three states. Now, if you want to define colloidal state, how to define? It is a state. It is a state in which the size of the particle are in between 1 to 1000 nanometer, very small size, 1 to 1000 nanometer, and like this you can write the definition, and they can pass through filter paper, but not through the membrane. So it is a state in which the size of particles are in between 1 to 1000 nanometer. This is the size of particle in case of colloidal state, and they can pass through filter paper but not through the membrane. They cannot pass through the membrane. And in colloidal solution, you know, normally in a solution it contains some solute and solvent when you prepare a solution. In colloidal solution, the solute is called disperse phase. The solute is called disperse phase, and the solvent is called dispersion medium. These terms are used only in colloidal solution. Normally in normal solution we use solute and solvent, but here we don't use solute solvent. Instead of solute you have to use disperse phase. So disperse phase means nothing, it represents solute, and dispersion medium means it represents solvent. So here when we study colloidal state of matter, we will not use the solute solvent concept. Here we will use disperse phase and dispersion medium. Disperse phase means solute, dispersion medium means solvent. So this is about colloidal state of matter. Thank you.